Okay, so the last unit we spoke about, sorry, let me just close the shades. In the last unit we spoke about, there we go, the idea of the quadratic equation. So we looked at the quadratic equation, ax squared plus bx plus c equals 0. And the question was, this is the quadratic equation, this is the quadratic formula, okay? B squared minus 4ac over 2a. We were able to use this equation to find the roots of the equation, but we were able to use this equation to tell us something about the parabola y equals ax squared plus bx plus c. And what we said was, if we look at the expression under the radical bx squared plus b squared minus 4ac, we saw that if b squared minus 4ac was greater than 0, then the parabola touched the x-axis in two locations. We saw that if b squared minus 4ac equals 0, that it was tangent to the x-axis. So there was like a double root. For example, the equation x squared, well, I can simply write x minus 3 times x minus 3. It's quadratic. There's two roots. They're both 3. How does that, and as a parabola, it just kind of touches the x-axis. Okay, and then the last situation was if b squared minus 4ac was less than 0, then we saw that the parabola of this quadratic didn't touch the x-axis at all. It still has an axis of symmetry, it still has a turning point, and it still has a y-intercept, but in this case, there's no real roots, because we're going to have a negative number under the radical. It's outside the scope of this class. Now, an application that they like to use is they ask these questions. They say a line and a parabola, like you graph a line and a parabola. And they'll say, given these two equations, how many places does the line and the parabola intersect? And if you think about it, we look at a line versus a parabola, right? There's 3 situations. Either the line passes it in 2 places, either the line passes it, in 1 place. We're going to see this in calculus. And then the other situation is that we have a parabola and the line doesn't touch it. Okay, so in the situation, you're going to be giving a line and a parabola. So how about we say, in how many places does the parabola y equals x squared and the line y equals 2x plus 5 intersect? Now, you can do it visually. You can say, Mr. Elder, I can see that this is the parabola x squared, and I know that this is the line 2x plus 5, y equals 2x plus 5. So you would say, I can see that the line and the parabola intersect in 2 places. The question is, how do we do this algebraically? Well, to determine, are we good? Space? Yeah. Oh, sorry. So what we would do is, first, we would set the parabola equal to the line, right, equals 2x plus 5. Then we would set it equal to 0. So we have x squared minus 2x minus 5 equals 0. And then we would evaluate the discriminant. Evaluate the discriminant. Discriminant. And it's the same idea as the nature of the roots questions. If b squared minus 4ac is greater than 0, then the parabola and the line intersect in 2 places. If b squared minus 4ac is equal to 0, then we're going to have a situation where the parabola, the lighting in here is just horrible, and if b squared minus 4ac is equal to 0, then we have a situation where the line, let me write it over here, the line and the parabola meet in one place. It's a horrible diagram, sorry. As I said before, this is going to show up in the calculus unit. This is known as our tangent line. The last situation is that b squared minus 4ac is less than 0, and that tells us that the line and the parabola have no points of intersection. No points of intersection. And so I can take a look at this example right here and say, you know what? A is 1, B is negative 2, and C is negative 5, and therefore the discriminant is equal to b squared minus 4ac, which is 4 plus 20, or 24. Because the discriminant is greater than 0, we see that this parabola and line intersect in two places. Let's try another example. How about, what do you think? How about the parabola y equals x squared, let's see, plus 6x, and y equals negative 9. What do you think? Well, first step, set them equal to each other. Maybe you want to do a sketch. That's totally fine. Yeah, or let's just jump right in. Step 1, set them equal to each other. So we have, I apologize. Yeah, but let's just do it algebraically quick. So step 1, set them equal to each other. X squared plus 6x equals negative 9. Step 2, set it equal to 0. X squared plus 6x plus 9 equals 0. Step 3, identify the coefficients and determine the determinants. Well, A is 1, B is 6, and C is 9. So we have b squared minus 4ac, that equals 0. It turns out that this parabola and line intersect in one location. Now, how do I figure this out? Well, let's think about this. Y equals negative 9, that's easy to sketch. That's down here. Y equals negative 9. The question is, how do I sketch the graph of x squared plus 6x? Well, I know that the zeros, because if I set this equal to 0, I have 0 and negative 6. That means I know, right? Let's think about this. The zeros, x squared plus 6x equals 0. Factor out an x plus 6 equals 0. X equals 0, x equals negative 6. Right? Now, because 0 and negative 6 are my zeros, negative 3 is the axis of symmetry. That means that when I plug negative 3 in here, I get 9 minus 18, I get negative 9, and my parabola looks like this. And we can see that this parabola and this line intersect in one place, where we say the line is tangent to the parabola. Last example. For which values of k does the parabola y equals x squared minus 5x and the line y equals 2x plus k have no points of intersection. Well, let's think about this. It's the same problem, but now there's a k in there. Well, parabola and a line, where do they meet? Same steps. Why don't you try it on your own? Okay, we're back. Well, set them equal to each other. X squared minus 5x equals 2x plus k. Set it equal to 0. Right? Determine the... Okay, so this is good. So A is 1. B is negative 7. And C is negative k. Don't forget the negatives. Determine the discriminant. Negative 7 squared minus 4 times 1 times negative k. But we say that we want no points of intersection, so this expression must be less than 0. So we have 49 plus 4k is less than 0. 4k is less than negative 49. K is less than negative 49 over 4. And that's how we do these problems. Some of them might get a little more advanced, but you know what? You all did so well on the first test. I know that you can handle these.